The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Alright, so I'm going to work through problem number 7 for the Physics 2020 Midterm Exam 2, year 2006. And it says a 60-kilogram soccer player traveling at 5 meters per second collides with a 75-kilogram player who is traveling at 2 meters per second in the same direction. Upon collision, they grab and hold on to each other. What is their common speed immediately after the collision? Right, so I kind of have a illustration of the problem statement. It's very crude. Don't make fun of my drawing here. But we have a soccer player who we're calling M1, has a mass of M1, which is 60 kilograms. He is traveling at 5 meters per second. So his initial velocity is equal to 5 meters per second. And then he's running towards a 75 kilogram player. We call that M2. His mass is M2. And he's traveling at 2 meters, so his initial velocity is 2 meters per second. And then they collide with each other, and they hold on to each other, and then so what is going to be their final velocity of their, when the two masses or the two bodies are stuck together. And so the important piece of information in this problem is knowing that the two players are holding on to each other. So they hold on to each other. So they're stuck together. And we know that in collision theory, when two masses are stuck together, we know that kinetic energy is not conserved and momentum is conserved. Okay, so momentum is conserved, kinetic energy is not conserved. Alright, and basically we have a inelastic collision. Okay? So if you go to your formula review sheet and look on the 3rd page, you will see information for inelastic collision, and you will have you'll see that that for when two bodies are stuck together, that kinetic energy is not conserved, but momentum is conserved. And we know that momentum is defined as the mass times the velocity. So it's the mass of an object times the velocity at which that object is moving. That is what we call momentum. And so if we know that the momentum is conserved, we know that if we're talking about two bodies, we have one body moving at an initial velocity plus the second body moving at an initial velocity is equal to the two bodies are stuck together times their final velocity, and we call this with a capital V. Okay? So we know that the initial momentum is equal to the final momentum. That's what the conservation of momentum means. Alright, and so in this particular problem we're asked to find the final velocity that the two masses are, when their two masses are moving together. So we can easily solve this equation for capital V. Capital V is going to be M1 So we're going to get that equation when we solve for capital V. And now we can just substitute in the information. Alright, and so if we substitute in the information, we get the mass of the first one is 60 kilograms multiplied by its initial velocity, which is 5 meters per second, plus 75 kilograms times 2 meters per second, divided by 60 plus 75 kilograms. Okay, so this is just substituting in the information that was given in the problem. And when we do the calculation, this works out to be 3.3 meters per second. Alright, and we get meters per second because we'll have units of kilograms on the top, which cancel out with kilograms on the bottom, and so we're just left with meters per second. And that is the solution to the problem.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.